This is worksheet number 10.em.03.03 under level 2. Level 2, unit 3 polynomials, topic relationship between zeros and coefficients of a polynomial. Now let us see worksheet assignments. Find the zeros of the polynomial 6x cube plus 5x square plus 7 minus 20 and verify the relationship between zeros and the coefficients. This is a cubic polynomial. Let us say the zeros of the cubic polynomial are alpha, beta, and gamma. The general form of cubic polynomial is ax cube plus bx square plus cx plus d, where a is not equal to 0. Then the relationship between zeros and the coefficients. The relations are alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a. Alpha into beta into gamma is equal to minus d by a. These are the three relations between zeros and coefficients in case of cubic polynomial. Here we have a cubic polynomial. We need to find the zeros. Generally, we employ factor theorem to find one zero. Later on, when we get quadratic polynomial as a quotient, we'll use some factorization method to find the factors of quadratic polynomial. Now, let us take this polynomial. Now we have to apply factor theorem. If p of k is equal to 0, then x minus k is a factor of p of x. So we'll go on taking values for k and check whether p of k is 0. Instead of taking every value of k, we can choose certain values for k and confirm whether there are any rational zeros or not. That is Rational Zeroes Theorem. Or rational root test. Using this rational zeros theorem, we can test for only some possible rational zeros and confirm whether there are any rational zeros or not. How do we apply this rational zeros theorem? We have to take constant term and the coefficient of highest degree term. Here the constant term is minus 20. Coefficient of highest degree term. Here it is 6. We have to find all possible values of factors of minus 20 and all possible values of factors of 6. We can take minus 20 or say 20. What are the possible factors or what are all the factors? The factors of 20 are 1, 2, 4, 5, 10, 20. Then What are the factors of 6? This is constant term. This is coefficient of highest degree term. All factors of 6. What are the factors of 6? 1, 2, 3, and 6. Now using these factors of constant term and factors of coefficient of highest degree term, we can find the possible rational zeros of a, a polynomial. Possible rational zeros. One by one. Here, if a, this is P, if this is Q, we have to take P by Q. We can take plus or minus. These values are the possible rational zeros. Here, what are the values? 1 by 1, 1 by 1, plus or minus 1 by 1, plus or minus 2 by 1, plus or minus 4 by 1, plus or minus 5 by 1, plus or minus 10 by 1, plus or minus 20 by 1. Then divide by 2. We have completed division by 1. Now plus or minus 1 by 2, plus or minus 2 by 2. 2 by 2 is 1 by 1. So we did not take this. Then plus or minus 4 by 2. This is equal to plus or minus 2. We have already covered this one. So we need not take this also. Then plus or minus 5 by 2. Plus or minus 10 by 2. This is 5. We have already covered. Then plus or minus 20 by 2. This is plus 10. We have already covered. Now divide by 3. Plus or minus 1 by 3. Plus or minus 2 by 3. Plus or minus 4 by 3. Plus or minus 5 by 3. Plus or minus 10 by 3. Plus or minus 20 by 3. Then divide by 6. Plus or minus 1 by 6. Plus or minus 2 by 6. This is already covered here. Then plus or minus 4 by 6. This is 2 by 3. This is already covered here. Then plus or minus 5 by 6. Then plus or minus 10 by 6. This is 5 by 3. This is 5 by 3. This is already covered here. Then plus or minus 20 by 6. This becomes 10 by 3, already covered here. So we have obtained all the possible rational zeros. These are only possible rational zeros. These are only possible rational zeros. We cannot say that these are the zeros. Now we can check P of k, taking the values of k as this plus or minus p by q. If there is any value of k or plus or minus p by q for which p of k is equal to 0, then x minus k is a factor, which means k is a 0. In this case, we find that there is no 0 at all. That means for this given cubic polynomial, for this given cubic polynomial, there are no rational zeros. See here, I have found out the roots of the polynomial. The roots are here x1. This is not a rational number actually. This is an approximation of an irrational number. This is only one real root we have. The other roots are complex roots. We have only one real root, and that real root is not a rational root. It is an irrational root. Now let us go to the second one. Find the zeros of the polynomial x cube plus 4x square minus 25x minus 100 and verify the relation between zeros and coefficients. So p of x given is x cube plus 4x square minus 25x minus 100. Here we have to use factor theorem to find one zero. So we will find one factor, one linear factor. By dividing using that linear factor, we'll obtain another quadratic polynomial. So first, how do we find one linear polynomial? We have to use factor theorem. So we have to use p of something. Some value we have to take and verify whether p of that value is 0 or not. We can use rational zeros theorem. This rational zeros theorem gives the possible rational zeros. We have to take the constant term and the coefficient of the highest degree term. Here the coefficient of highest degree term is 1. So we can simply take the factors of constant term 100. So what are the factors of 100? Factors of 100 are 1, 2, 5, 10, 20, 25, 50, 100. We can take plus or minus for these values. So first we'll go with plus or minus 1. We can take p of 1 or p of minus 1. Now let us find out what is p of 1. P of 1 is equal to 1 cubed plus 4 into 1 square minus 2 into 1 minus 100. This is equal to 1 plus 4 minus 25 minus 100. This is 5 minus 125. This is minus 120. This is not equal to 0. What is p of minus 1? Minus 1 whole cubed plus 4 into minus 1 square, 4 into minus 1 square minus 25 into minus 1 minus 100. This is equal to minus 1 plus 4 plus 25 minus 100. This is equal to minus 101 plus 29. This is also not equal to 0. Now here we can go for 2 and then we can go for 5. Let us first say take 2. P of 2. P of 2 is equal to 2 cubed plus 4 into 2 square minus 25 into 2 minus 100. This is equal to 8 plus 16 minus 50 minus 100. So this is 24 minus 150. This is not equal to 0. P of minus 2. This is minus 2 whole cubed plus 4 into minus 2 whole square minus 25 into minus 2 minus 100. This is minus 8 plus 16 plus 50 minus 100. This is equal to minus 108 plus 66. This is also not equal to 0. Now let us go for third possible 0 plus or minus 5. First let us take p of 5. 5 cubed plus 4 into 5 square minus 25 into 5 minus 100. 5 cubed is 125. 2 into 5 square is 25 minus 25 into 5 is 125 minus 100. This is 125 plus 4 into 25 is 100 minus 125 minus 100 plus 125 minus 125 plus 100 minus 100. So this is equal to 0. So we obtained 5 as a 0. 5 is a 0 of p of x. So x minus 5 is a factor of p of x. Now we have to find the coefficient, the quotient. When we divide p of x by x minus 5, we get a quotient. X minus 5, this is x cube plus 4x square minus 25x minus 100. We have to divide this by x minus 5. Then we will get a quadratic polynomial. We can factorize that quadratic polynomial and find two linear factors. Now let us divide this by x minus 5. So here x cube by x, this is x square. X square is the first term of quotient. X square into x minus 5. We get x cube minus 5x square. We have to subtract this. So change the signs, minus here, plus here. 4x square plus 5x square, this is 9x square minus 25x minus 100. We can drop down minus 1 minus 100 here itself, or we can drop down later also. Now the first term of this remaining dividend is 9x square. The first term of the divisor is x. 9x square by x. This is 9x. The next term in quotient is plus 9x. 9x into x minus 5. We get 9x square minus 45x. We have to subtract this to change the signs of the terms. This is minus, here it is plus. These get cancelled. Minus 25x plus 45x. This is 20x minus 100. The first term here is 20x. So 20x by x, it is 20. The next term in the quotient is plus 20. 20 into x minus 5, we get 20x minus 100. Subtracting, we get 0 as a reminder. Our p of x can be written as x minus 5 into, what is the quotient here? X square plus 9x plus 20. X square plus 9x plus 20. Now we have to factorize this quadratic polynomial x square plus 9x plus 20. X square plus 9x plus 20. We have to find factors of 20. Here it is the quotient of x square term is 1. So 1 into 20 is 20. We have to find factors of 20 whose sum is 9. M into n is 20. M plus n. M plus n is 9. So immediately we can find 4, 5. 4 into 5 is 20. 4 plus 5 is 9. So we can write this as x square plus 4x plus 5x plus 20. We can write it as x into x plus 4. Here we can take 5 as a common factor out. Then 5 into x plus 4. This can be written as x plus 4 into x plus 5. So, so p of x is equal to x minus 5 into x plus 4 into x plus 5. So from this, the zeros are alpha is equal to 5, beta is equal to minus 4, gamma is equal to minus 5. These are the zeros of this cubic polynomial. Now let us check the relationship. Alpha plus beta plus gamma is equal to 5 plus minus 4 plus minus 5. 5 and minus 5. They are cancelled. The sum is 0. So it is equal to minus 4. Alpha plus beta plus gamma should be equal to minus b by a. Now let us check what is minus b by a. What is our polynomial p of x? P of x is equal to x cube plus 4x square minus 25x minus 100. So a is equal to 1, b is equal to 4, c is equal to minus 25, and d is equal to minus 100. Now minus b by a is minus of b is 4 by a is 1. This is equal to minus 4. So we verified this one. Verified alpha plus beta plus gamma is equal to minus b by a. Let us take another relation. Alpha is equal to 5, beta is equal to minus 4, gamma is equal to minus 5. Alpha beta plus beta gamma plus gamma alpha is equal to 5 into minus 4 plus minus 4 into minus 5 plus minus 5 into 5. This is minus 20 plus 20 minus 25. This is equal to minus 25. Now this relation should be alpha beta plus beta gamma plus gamma alpha should be equal to c by a. Let us see whether c by a has same value. What is c? C is minus 25, a is 1. C is minus 25 and a is 1. So c by a is minus 25. So this relation is verified. Verified alpha beta plus beta gamma plus gamma alpha is equal to c by a. Now let us find alpha into beta into gamma. 5 into minus 4 into minus 5. This is equal to 5 4s are 20. 20 into 5 is 100. Minus into minus is positive. Positive 100. Alpha beta gamma should be equal to minus d by a. We have d is equal to minus 100 and a is equal to 1. So minus d by a is equal to minus of minus 100 by 1. This is equal to 100. So verified alpha beta gamma is equal to minus d by a. Third question, find the zeros of the polynomial 2x square minus 8x plus 6 and verify the relationship between zeros and coefficients. So given polynomial p of x is 2x square minus 8x plus 6. This is quadratic polynomial. Now let us find the zeros. To find the zeros, let us first find the factors. P of x is equal to 2x square minus 8x plus 6. These three terms have a common factor 2. So we can take out 2 as a common factor. We can take out the common factor 2. 2 into x square minus 4x plus 3. Now we have to factorize only this one, x square minus 4x plus 3. So 2 into this one only. Here we have to find factors of 3 whose sum is minus 4. So minus 1 into minus 3 is 3. Minus 1 plus minus 3 is minus 4. So we can write this as x square minus x minus 3x plus 3. This is 2 into, here we can take common factor x out. So x into x minus 1. Here we can take minus 3 because we have to get x minus 1. So from minus 3x, we'll take minus 3 as common factor out. Minus 3 into x minus 1. Now this can be written as 2 into x minus 1 into x minus 3. Now we can equate this one to 0. P of x equal to 0 to find zeros. We get zeros. Alpha is equal to 1, beta is equal to 3. Let us simply denote them as alpha and beta. Now what are the relationships between zeros and the coefficients? Sum of the zeros, alpha plus beta, is equal to minus b by a. Alpha into beta, product of zeros, is equal to c by a. Given polynomial p of x is 2x square minus 8x plus 6. We have to compare this with the general form of quadratic polynomial, ax square plus bx plus c. Then we get the values as a is equal to 2, b is equal to minus 8, and c is equal to 6. So first one, let us say alpha plus beta. What is the value? Alpha is 1, beta is 3. So it is 4. Now what is minus b by a? Minus b value is minus 8 by a value is 2. This is 8 by 2, which is equal to 4. So verified alpha plus beta is equal to minus b by a. Now let us take second relationship. Let us find alpha into beta. Alpha is 1 and beta is 3. 1 into 3 is 3. Then what is c by a? C is 6 and a is 2. 6 by 2 is 3. alpha beta is 3 and C by A is also 3. So verified alpha beta is equal to C by A. Fourth question, find the zeros of the polynomial 5x square plus 6x plus 1 and verify the relation between zeros and coefficients. Given p of x is equal to 5x square plus 6x plus 1. Now we have to take the product of x square coefficient and constant. 5 into 1 is 5. We have to find the factors of 5 whose sum is 6. Clearly the factors are 5 and 1. 5 into 1 is 5, 5 plus 1 is 6. So this can be written as 5x square plus 5x plus x plus 1. We can take the common factor 5x out. 5x into x here and 1 here. Here also we have to obtain x plus 1 as a remaining factor, So we have to take the common factor 1 out. So 1 into x plus 1. This can be written as x plus 1 into 5x plus 1. By equating this to 0, we get the zeros. So zeros are alpha is equal to minus 1 from this one, equating this one to 0. Equating this one to 0, we get x is equal to minus 1. So alpha is minus 1 and beta. By equating this one to 0, we get minus 1 by 5. Now let us check the relation alpha plus beta. Alpha plus beta is equal to minus 1 plus minus 1 by 5. This is minus 1 minus 1 by 5. Taking 5 as denominator for both, we get minus 5 minus 1. This is minus 6 by 5. Now alpha plus beta should be equal to minus b by a and alpha into beta should be equal to c by a. Here p of x given is 5x square plus 6x plus 1. Now comparing this to general form of the quadratic polynomial, we get a is equal to 5, b is equal to 6 and c is equal to 1. Here what is minus b by a? Minus of b is 6 by a is 5. So we get minus 6 by 5. They are equal. So it is verified that alpha plus beta is equal to minus b by a. Now let us verify the second relation. Alpha into beta. Alpha is minus 1. Beta is minus 1 by 5. This is equal to 1 by 5. Alpha into beta should be equal to c by a. Then what is c by a? Value of c. Value of c is 1. Value of c is 1. and a is 5. So this is 1 by 5. We get 1 by 5. So it is verified. Alpha beta is equal to c by a. Find the zeros of the polynomial x square plus 5x minus 3 and verify the relationship between zeros and coefficients. Here p of x is equal to x square plus 5x minus 3. So minus 3, this minus 3 should be split into two factors. We have to find two factors m and n whose product is minus 3 and whose sum is 5. What are the factors of 3, 1 and 3 only? So minus 3 can be written as 1 into minus 3 or minus 1 into 3. 1 plus minus 3 is minus 2. Minus 1 plus 3 is 2. The sum can be minus 2 or 2 only, but not 5. So it is not possible for us to find the factors. Let us find algebraically. M plus n is 5. Let us find m minus n. M minus n whole square is m plus n whole square minus 4mn. So this becomes 5 square minus 4 into minus 3. This is 25 plus 12. This is 37. So m minus n is square root of 37. M minus n is square root of 37. Now we will get some irrational roots. So let us leave it here. Sixth question. Find the zeros of the polynomial 5x cube minus 4x square plus 7x minus 8 and find the relation between zeros and coefficients. So given p of x is equal to 5x cube minus 4x square plus 7x minus 8. Now we have to find 1 0 using a factor theorem. We can use rational zeros theorem to list out possible rational zeros. We have to take the factors of 8 and also the factors of 5. Factors of 8 are 1, 2, 4, 8. This should be divided by factors of 5, 1, 5. Then what are the possible rational zeros? 1 plus or minus 1 by 1 plus or minus 2 by 1 plus or minus 4 by 1 plus or minus 8 by 1. Then plus or minus 1 by 5 plus or minus 2 by 5, then plus or minus 4 by 5 plus or minus 8 by 5. So in 10th class, you need not do all these things. Just keep in mind, in case you get a difficult problem, you can work out these things and find out which one we can verify. So first we have to verify 1, then 2, then we have to skip 3, then go for 4, like that. So we'll get a clue from these things. Otherwise, you will be go on adding whatever number you want. In that way, sometimes you may be put into difficulty. So this will guide you. So first, let us find p of 1 or minus 1, p of 1 here. So 5 into 1 cubed minus 4 into 1 square plus 7 into 1 minus 8. This is 5 minus 4 plus 7 minus 8. 5 plus 7 is 12. Minus 4 minus 8 is minus 12. This is 0. 1 is a 0 of p of x. 1 is a 0 of p of x. So x minus 1 is a factor of p of x. Now we have to find the other factors. To find the other factors, we have to divide the p of x, polynomial p of x, by the factor x minus 1. So let us divide x minus 1. What is the p of x? 5x cubed minus 4x square plus 7x minus 8. First term here is 5x cubed. First term in the divisor is x. 5x cubed by x is 5x square. The first term, this is the first term of the quotient, 5x square. 5x square into x minus 1, we get 5x cubed minus 5x square. We have to subtract this, change the signs. These get cancelled. Now minus 4x square plus 5x square, we get x square. We can bring down 7x. This is enough. Or else we can bring down this now itself. Now in the remaining dividend, first term is x square. So x square by x, we get x. This is the next term in quotient. X into x minus 1. We get x square minus x. Change the signs to subtract. Minus here plus here. These get cancelled. 7x plus x is 8x minus 8 brought down. The first term in the remaining dividend is 8x. 8x by x, we get 8. This is next term in quotient. Next term in quotient is 8. 8 into x minus 1. This is 8x minus 8x. 8x minus 8x. So we get remainder 0. So p of x can be written as x minus 1 into 5x square plus x plus 8. 5x square plus x plus 8. Now we have to factorize this quadratic polynomial. 5x square plus x plus 8. Now multiply 5 and 8. This is 40. We have to find factors of 40 whose sum is 1. M into n is 40. M plus n is 1. Let us find m minus n. M minus n whole square is equal to m plus n whole square minus 4mn. This is 1 square minus 4 into 40. This is 1 minus 160. So we are getting minus 159. M minus n is square root of minus 159. So we are going to get complex root. The roots are not real.